Hello, class. This will be a recorded lecture to finish section 1.4, which is solving radical equations. So we went through one example in the previous video recorded lecture. And what I'd like to do now is to walk through one more and kind of show you how things get real complicated as well. The good news is I'm just going to show you the real complicated stuff. I'm not going to ask you to actually solve that. So again, one that you would be responsible for would be one that looks like this. X equals 2 square root of 3x. That looks like that's minus 9. So again, the strategy is you want the radical on one side of the equation, or the square root on one side, and the x on the other. And so if there was a minus 2 here, you would move it over, etc. But what do we do with this 2? Well, because it's multiplied by, it's multiplied with the square root, you can just leave it there. And that's why I'm doing this example, to kind of show you how to deal with that. So with regards to rewriting this, I always like to rewrite it and get rid of the square root sign, or get rid of the root sign and put the fractional exponent up there. Because then it helps me make sure that I do this correctly, where to get rid of that, you want to square both sides. But notice that when you square both sides, in this case, you're squaring not only the 1/2, but you have to square the 2 with it as well. And so that's how you deal with it. So in this case, you get x squared. And so 2 squared would be 4. And then 1/2 times 2 gives us 1. So that would be 4, 3x minus 9. So when you watch this, if you have any questions on that maneuver, please ask me during our Zoom class. But it's this, take the 2 and you square it, so you get 4. And then this multiplication here gives us 1. And so we get the 3x minus 9. So now we solve this again like a normal quadratic. Expand this out, you get 3, whoops. 4 times 3 is 12, not 4, 4x, and then that would be minus 36. So what's the strategy? Again, everything to one side of the equal sign and then have it equal to 0. I personally like to have the a value +1 if possible in this case. So what I would do is I would bring both of these over. It just, for me, makes it a little bit easier to solve. But if you did it the other way, that is fine too. So you would get x squared, you bring the 12x to the other side, it's minus 12x. You bring the minus 36 to the other side, you get plus 36 equals 0. And again, if you could use a quadratic formula, but we're in a math class, most of these are factorable, you'll see. And you can see that here, 6 times 6 gives us 36. But if we do minus 6 times minus 6, that's still 36. But when you add those together, you get minus 12. So that would be x minus 6 times x minus 6 equals 0. So this is, again, what we kind of call a perfect square. So you actually have 2 solutions, right? But both solutions are exactly the same number. So we have x minus 6 equals 0. X equals 6, and then we do the same thing again. And some of you might be saying, can we write it this way? Yes, the answer is yes, that we could rewrite the equation squared, because there's 2 of them, equals 0. So do we have to check the 6? Yes, we do. So if you use the quadratic formula, and you solve this equation, which is 100% okay, you would find that b squared minus 4ac in this case would actually give you 0. And that's the occurrence of only a single solution in the quadratic And so I'll let you do that on your own time if you like, or we could do it in class and show you that if there's questions on that. But to finish this problem here, I also want to make sure that we check the 6 and see how it goes. So x equals 6, so that would be 6 equals 2 times the square root of 3 times 6 minus 9. So that would be 6 equals 2 square root of 18 minus 9. So 18 and 9 is 9, right? So that would be 2 times 3, and that equals 6. So we are good. So this solution actually does work. So the solution to this problem would be x equals 6. So I kind of show you the PowerPoint presentation. And some of this we didn't go over, so you're not responsible for it. But I do want to show you, we did this last lecture, and I have the solution set in the PowerPoint as well. And so here's another example, which is very annoying because it's kind of complicated. I'm not going to ask you to physically go through this, but I kind of want to explain to you the strategy. And so if you get into some higher level math classes, you might end up having to solve equations like this. And the strategy is that you can think about the number of square roots that you see is the number of times you have to square the equation. So on the first equation, we have just the 1 square root. So you only have to square that equation 1 time to get rid of all of them. In this case, we have 2 square roots. So this would require multiple or 2 times to do the square to get rid of it. And again, when you see the homework, I don't put any of these to solve in the homework, but I do just want to point out the strategy. So the strategy in this case is you move the radical or the square root on one side and everything else on the other, and you see how we square it. So you walk through this and you can see that the algebra starts to become a little bit complicated, and I would consider a little bit of annoying, but if you walk through the process, you would get it. And then you get to the point where you get to this equation right here. X minus 3 equals 4, x plus 2. And you see we still have one more square root thing we have to get rid of. And that's the strategy of squaring both sides again to get rid of the square root. So you can see in this case, to do this problem, you have to square 2 times. To be really torturous, if you got a problem with 3 square roots in it, you would have to do it 3 times, and so on and so forth. So I wanted to point that out, but like I said, all the problems that you're going to be responsible for that you're solving for x will just have a single square root. So this ends the recorded lectures for section 1.4, which is solving radical